Welcome back, student. So in this session, in this class, we are going to solve one more problem, not only on matrix minima method and also on northwest corner rule. What I do, I divide the board into two halves. So in this half, the same problem is solved using northwest corner rule, and here in this half we are going to solve it by matrix minima method. So let us see whether we get the same solution or not. Directly I will draw the table, that is demand and supply table, and solve. Fine. So we are going to solve it by northwest corner rule here. So this is what the table is: D1, D2, D3, followed by D4, and it is supply, and it is O1, O2, O3, and it is demand. Fine. So let us add some interest on these two methods. Fine. To generate an interest in the two methods, what I do here, I solve from both methods. One problem by both methods. Right? It is 1, 2, 3, 4. Fine. Followed by 4, 3, 2, 0. Then followed by 0, 2, 2, and 1. Let me write the supplies: 6, 8, 10, then 4, 6, 8, 6. Total is 24 here. So we will solve this by what? Northwest corner rule. We will solve this by northwest corner rule. So how it is solved by northwest corner rule is that the location starts from the northwest corner. So this is the northwest corner. What happens here in this northwest corner? So we will start allocating with this here. So what happens? Check out the demand and supply here. Write out the minimum. So minimum is 4 here. Right? Minimum is 4. That is 4 minus 4 is 0. Then 6 minus 4 is 2 here. Fine? The allocation is done. Next comes, so this row is 0. Come for the next row. Here, next row. So check out the supply and demand. So this is 2, minimum is 2. So 2 minus 2 is 0. 6 minus 2 is 4. So this row. Then when this row got exhausted, come for the next row. Here. So what is the supply and demand here? So minimum is 4 here. 4 minus 4 is 0. So it is 8 minus 4 is 4. So this column is got exhausted. Come for the next column. Here it is 4 and 8. Let me write 4 here. So 4 minus 4 is 0. Here it becomes 4. So this row got exhausted. Come for the next row. Here I come. So here it is 10 and 4. Let me write 4. So it is 0. Then it becomes 6. Fine. Now come for the next column. Here it is 6. 6 minus 6 is 0. 6 minus 6 is 0. Fine. This is done. All rows, that is this row, this column, this column, this row, this row, this row got exhausted. Even this column also exhausted. Now the allocation is X11 is 4, X12 is 2, so X22 is 4, X23 is 4, X33 is 4, X34 is 6. So total transportation caused by north west corner rule is equal to 4 into 1 plus 2 into 2 plus 4 into 3 plus 4 into 2 plus 4 into 2 plus 6 into 1, that is equal to 4 into 4 is 4 plus 2 into 2 is 4 plus 4 into 3 is 12, 4 into 8, 4 into 2, 8, 6 into 1 is 6, 1, 2, 3, 4, 5, 6. So total allocations, that is how much? 6 less than m plus n minus 1, that is 6 is less than how much? 6. So what happens here? Non-degenerate solution. So answer is how much? 8, 20, 28, 36, 42. So rupees 42. This is 8, 20, 28, 28 plus 8, 36, 36 plus 6 is 42 rupees. So this is what the solution we got. Solving the transportation problem using northwest corner rule. This is what initial basic feasible solution. Because what happens here? Since summation AI is equal to summation Bj is equal to 24, therefore the transportation problem is balanced and there exists initial basic feasible solution. Fine. So now we try it by least cost or matrix minima method. Fine. So again, let me draw the table here. That is V1, that is V2, that is D3, D4, supply followed by O1, O2, O3, followed by demand. Here it is. Let me draw the table. Fine. So let me write the values. It is 1, 2, 3, 4. Then 4, 3, 2, 0, 4, 3, 2, 0, 0, 2, 2, 1, 0, 2, 2, 1. Let me write the supplies here. It is 6, 8, 10. It is 4, 6, 8, 6. The total is 24. So we need to solve this by least cost, or it is called as matrix minima method. So here we need to find the smallest cost among the cost matrix of the transportation table in this method, whereas in this method we start from the northwest corner. So here we need to find the smallest cost. So this is what the smallest cost. There are two smallest costs here which are same. Choose any one. So let me choose this one. So number 1. So first allocation we do in the cell. What is it is 0, so it is 3 comma 1. So we find what x31 is equal to minimum of, that is 10 comma 4. This is 10 and this is 4. That is what 4. So let me write 4 here. What happens? This 4 minus 4 becomes 0. 10 minus 4 it becomes 6. So this complete row will be exhausted. Fine. So the second allocation is done in the cell. I mean to say here, because it is the minimum, that is 2 comma 4. So we find x24 is equal to minimum of, here it is 8 comma 6, that is equal to 6. So let me write 6 here. So 6 minus 6 is 0, 8 minus 6 is 2. So this complete row will be exhausted. So the next allocation is made in the cell to find out the minimum among these. So let me choose this one because 2, 2, 2, 2 here. So I will choose arbitrarily, that is 3 comma 2. So we find x32 minimum of, here it is 6 comma 6, that is 6 only. So let me write 6 here. This is 0 and this is also 0. So let me choose arbitrarily this one. Fine. So fourth allocation is made in the cell. So this is what the remaining. Let me do it. Do it here or here or here. Both of this. So this is 2 here. So let me allocate here. So let me do allocate in the cell 2 comma 3. So we find x23 minimum. So what here 23? So what is the minimum here? 2 comma 8, that is 2. So let me write 2 here. This will become 0 and this becomes 6. So this row got exhausted. So fifth one, allocation. So there are only 2 remaining here. So this is what the minimum. So it is done in the column 3, 3. So we find x33 minimum, that is here. So it is 0 comma 6. Fine. It is what 0 here. So let me write 0. It will become 6 only. And this is 0. Fine. So this is get exhausted. And the sixth is cell quad 1 comma 3. We find x13, that is minimum of what is 6 comma 6, that is 0. So let me write 6 here. This becomes 0 and this becomes 0. Let me, totally we have made this many allocations. So let me write allocations is equal to, so which allocation it is? Let me round off these allocations because I don't want to get confused. Fine. 4, 6, 0. Fine. So it is x13 is equal to 6, then followed by x23 is equal to 2, then it is x24 is equal to 6, then x31 is equal to 4, x32 is equal to 6, 3 is equal to 0. So it is what? 6 allocations less than m plus n minus 1. That is 6 is 3 plus 4 minus 1. So 6 is what? Less than 6. What happened? Non-degenerate solution. It is what? Non-degenerate solution. So total transportation cost by least cost method is equal to how much is? So that is 6 into 3 plus 2 into 2 plus 6 into 0 plus 4 into 0 plus 6 into 2 plus 0 into 2. So it is 18 plus 4 plus 0 plus 0 plus 12 plus 0. Is it 18 plus 4 plus 12? It is how much? 18 plus 4. 18 plus 4, it is 22. 22 plus 12 is how much? 32. 34 rupees. It is 34. Fine. So now comes what is the comparison between least cost and what? We can say matrix minima method. This is what initial solution. Fine. It is not compulsory. Both methods should have the same value. This is initial basic feasible solution by least cost, and it is initial basic feasible solution by northwest corner rule. How many allocations here? 6 allocations. How many allocations here? Here also 6 allocations. Let me check. 6 into 3, 2 into 2, 6 into 0. Fine. And then followed by 4 into 0. Then it is 6 into 2. Then it is 0 into 2. Then it is 5. So 1, 2, 3, 4, 5, 6 allocations. 6 into 3 followed by 2 into 2, 6 into 0, 4 into 0, 6 into 2, 0 into 2, 6 3s are 18, 2 to the 4, then 6 to the 12. 18 plus 4 plus 12 is 34. So here it is 34, here it is 42. Both values are different, but these values are not the final values. This is initial basic feasible solution using northwest corner rule for a transportation problem, and least cost or matrix minima method for the transportation problem. So this is what comparison. I think we had a repetition of both the northwest corner rule and least cost or matrix minima method. Fine. Thank you.